and B are two similar vases. Now, vase A has a height of 24, and that's our linear, and vase B has a height of 36. So the relationship between the two in terms of its linear amount, so let's do that's A, that's B, and this is linear. So that would mean that that was 36 over 24. So say that was x, that would be 36 over 24, which equals 1.5. So b is 1.5x. So if we then went on the quadratic, so if we then went squared or area, that would be x squared, and then that would be 1.5x. So that would be 1.5 squared times 1.5 equals 9 over 4 squared, and then for volume it would equal that times 1.5 equals 27 over 8. Anyway, so the surface area, so vase A has a surface area of 960, and therefore the surface area of vase B would be, oh good lord, my 9s and my 4s are very similar. 9 over 4, so we would do 9 over 4 times 960 equals 2160 centimetres squared. Vase B has a volume of V centimetres cubed. Okay, how would we find out what vase A would be? So vase A would be that times 8 over 27. Or is there another way of putting that? So it would be 8V over 27. And that's your answer. Because you've just done a little chart. Doing a little chart is a lot easier than not doing a little chart. Right, we're at the end where we start to do things I don't really like. The diagram shows PQR, and we need to calculate the length of PR and give your answer to 3 significant figures. Okay, so what do we know? We know 2 of the sides, that one, and we know 36 degrees. And this is not a square, this hasn't got a right angle, so it means we can't use SOHCAHTOA. So it means we have to use one of 2 things. One would be the sine rule, but we don't have the right things for the sine rule, so we're going to have to use the second thing, which is the cos rule. And the cos rule equals, I'm going to show you on here, you do always have it, but the cos rule is this one here. So it's the cosine rule is a squared plus b squared equals b squared plus c squared minus 2bc cos a. Now what we've got to do is make sure that we do the right thing when it comes to writing this up. So that means that we have, this would be little a, this is big A, and then that would be B and C. Those don't really matter. So in order to get it correct, we then fill this in. So we know a squared equals b squared plus c squared minus 2bc cos A. So here we go. So a squared, you could actually just put everything into a square root, but I'm not going to do that, equals, let's go 26.3 squared plus 17.8 squared minus 2 times 26.3 times 17.8 times cos 36. And that would equal 26.3 squared, let's just do this, plus 17.8 squared equals, so So that's 1008.53 minus, and then 2 times 26.3 times 17.8 times cos 36, 757.466 something or other, and then we make A, and then we'll just do that, because otherwise I often forget to do that. AC, so now we'll do 1008.53 minus the answer equals, and then we'll square root it. So square root the answer equals 15.8. Yeah, that's believable. So A equals, and what we've got to do is 3 significant figures, so 15.8 centimetres is the answer. There you go, that goes in there. Nicely done. And now on to the next one. Table gives the height of some trees. On the grid, draw a histogram for this information. Right, I didn't do histograms at school. I don't know, it might be after my time. So I have had one lesson on it. It consisted of this: frequency equals area. So we know, so what we've got to do is find the frequency density. So we'll find the height in meters, so that's 20 between that. And then to find the frequency density, we do 15 over 20, which is 0.75. And then we do, this is 15, and then we do 48 over 15, which is, I'm just going to check that on the calculator. 8 divided by 15 equals 3.2. Okay, that looks about right, so that's a good thing. This is 15, and then that's 21 over 15 is 1 point something, 1.4, and 10, so 16 over 10 is 1.6. Does make me worry a little bit, because I think we've got extraneous amounts of numbers there, but there we go, 48 over, that should do it. So our frequency density, so now we take 0 to 20 and we make that up to 0.75, so that's 7. That's what that is, and if you think about it, 20 times 0.75 gives us the frequency, so that doesn't work. Then we do 20 to 35, which is to there, and that goes all the way to 3.2. 15 times 3.2 really is I'm enjoying doing that too much. Right, and then 35 to 40 is tiny, so that's 1.4, so that's there. And then the last bit is 10, so that's to there, and that's 1.6. And that is how you do a histogram. It's not going to ask us a question, isn't it? Oh no, that's it. Right, fair enough. Oh good, this is circle theorems of some sort. So A, B, C and D are points on a circle. T, D, V is a tangent to the circle. Okay, and AB equals AD. So that is, I'm actually going to use a calculator, a ruler, because I didn't really like how I just did that. So that is a rather lovely, what's the word, isosceles triangle. There you go. Now, work out the angle for BCD. So that's that. And I'm just going to change that out. So now, what do we know? So if that's 71, we know that ABD, we know this one is also 71 because of alternate, so ABD equals 71 degrees because of alternate segment theory. I think there's another way to do that, but we won't worry about that. And if we know that that's 71, we know that the bases of a isosceles triangle are the same. So then we know that ADB equals 71 as the bottom or the bases of an isosceles triangle equal one another. And then we know, what's the next thing we know? So then if we know that that equals that, it was that, so we know that DAB is, I want another colour now. I think I'm just being greedy. So that would equal 180 minus 142, because the angles in a triangle add up to 180, and that would be 38. So we know that that's 38. In fact, we should probably write that in. So DAB equals 38 as angles in a triangle sum to 180. Now, you might be thinking, how am I going to find DCB based on this? Well, basically, we know that in a cyclic quadrilateral, which is something where it touches the sides all 4 times, we know that the opposite angles add up to 180. So we know that BAD or DAB plus BCD equals 180 because angles, opposite angles in a cyclic quadrilateral add to 180. So therefore we know we've got 38, and weirdly we already know the answer to this, plus it's going to be whatever that number is up there, 142 equals 180, therefore BCD equals 142 degrees. And that is our answer. We have given answers at all the points, but it is for 5 marks. I think if we don't write everything in, that we won't be given as many marks as we ought to be. Okay, oh, this looks fun. So right now,